Okay, so now with all that under our belts, we can now talk about parameter passing and how data flows into method calls and back out again. So I've set up a couple of methods here. Let's just walk through them. First of all, we reach this, we have this first method called whatever, because we don't really care too much about it. And inside of the method, we have a declaration of x. So we see int x. Sorry, we don't need to write the int down. We're not doing that. So x, and x gets a little slot that can hold a value. And right away, we're assigning it to a value of 3. The next thing that happens is that we call this method called not much, because it doesn't do very much. And the only thing that this method does is it takes a parameter and then it changes the value of the parameter to 5. So how this works mechanically is that this value of x is kind of piped into this new variable. So this parameter declaration is actually a variable declaration. It actually makes a little variable that's in the scope of this method, scope. And what I mean by the scope of this method is that it only lives as long as this method is alive. So it makes a little variable called num, and that's the first thing that it does. And the second thing that it does is it copies the value from the argument down into this parameter slot. So it just takes this and it copies it right down. So now num is also equal to 3. And then this method actually only does this one line of code. It just changes the value of num to 5. So the very first thing that it does is it changes this and it makes this equal to 5. And notice that x is not also changing. Num is changing locally within its scope, but there's nothing in here that says that x also has to change. We have no pointer back to x. We are just changing num in here. As soon as this method ends, we go back up to the call site. It returns back. It doesn't return a value, it just returns. So we come back to this call site and then we go to the next line of code, which is a declaration of y as an integer and an assignment of the value of x to that integer. And that just copies the value that's held inside of x up into y, and that value is still 3. Nothing that changed down here has actually changed x. Once again, because we didn't assign x a value, we just assigned this local value of num a value. Okay, so now that we understand how passing a simple primitive value into a method works, we're going to look at how to pass, or what happens when you pass an object. So here we have an object declaration, D, which is a dog, and as we know, it sets up our little reference. And here we have the instantiation of that dog. So we have dog instance here, and it does all the same stuff. So it barks, and it has a name. And we're going to name the dog Elisa, just to be self-aggrandizing. And then we're going to pass, and then this little assignment, of course, means that we have a reference from D to this dog object. Great. Now we're going to pass our dog, D, into our little method. And this time it's called bit more, because it does a little bit more. So we're passing D into bit more. So we call this method, and then the first thing that happens is it reads the parameter list and sets up these as kind of local variables. So we have my dog, and it gets its little reference spot. Now, what does not happen is that all of D is copied and a copy is made and given to bit more. That is not what happens. Instead, what happens is the reference is copied down. So here we have a reference from my dog back up to this original dog instance, which means that if we change the name of my dog to be Norm, it will change it over here, overwriting the Elisa name. And then when this method ends, this local value, this local variable dies. So this whole thing goes away when this method ends. And we return back to here, and we still have D, however. D is still a live reference to this same object. So we can still kind of get at this object. And so now if we print D.name, what will come out is Norm, because we have changed it in this place, referred to something within this local scope. Okay, so I've added another little line of code in this method, just so that we can roll back and see what would have happened if we had had a second dog instance that we created within this method. So let's walk through it all again. We've already got D, and we've got it assigned to this object instance. It's already named Elisa. Now we call our bit more method. And so that comes down here, and we declare our MyDog variable, and we end up copying this reference down, which means that we have a reference up to here. But then immediately what happens is we reach this new line of code. MyDog equals new dog. And that means that we're creating a new dog object. So we have a second one hanging around, dog instance 2. It wouldn't be named that inside the computer, but this is just for illustration. So we have our second dog instance, and it has all the same stuff, bark, name, whatever. I'll just put name in here. And then we change mydog.name, and then we assign new dog, this new dog, to MyDog, which kills this. It completely overwrites this reference, and it points MyDog to this new dog instance. MyDog equals new dog. Then when we change the name of MyDog, it changes in here. It doesn't change back up here. So we say MyDog.name equals norm, so we change this. Then the method ends. And as we know, this dies when the method ends because it was declared inside of the scope of this method. So this goes away, which means that we also totally lose our access to this instance. Effectively, it goes away too, from our perspective. And then when we come back up here and we say print d.name, we're going to get Elisa back out of here because we didn't actually change the name of this original object at all. We had already created our new object and we just changed it locally. So now we're going to continue our journey through parameter passing by looking at passing lists into methods. And spoiler alert, lists are just objects in Java, so they're passed in exactly as objects. You pass in the reference to them, you don't pass in the whole copy. But let's just walk through it just to get super crystal clear on this. So we've declared a list, nums, and then we have instantiated a new list. And instead of drawing the circle, I'm just going to draw it as a list. And it gets its little object name, so array list instance. And we never really need to remember this name. You should know that. And then the assignment statement means that this nums refers to this array list instance. Perfect. Now we're passing nums into this method creatively named useList. Okay, great. So we call this method useList. It sets up its local variable for myList, and gives it its little spot. And again, rather than copying the whole list down so that we get a local copy in here, no. Instead, what we do is we copy this reference down into myList, so that myList also refers to this same list instance. Great. Then we're calling mylist.add5. And that means that we travel along myList and we're adding the number 5 to that list. Then the method ends. Once the method has ended, this variable is no longer in scope, so it dies, and the reference dies. But we have another reference to this, so this one doesn't die. We still have it pointed to by nums. When we go back out of this method, we return to here. We see nums add 6. So we say, okay, nums, here we go, nums add 6. And now our array list instance, which we have referenced at the moment by nums, has 2 numbers in it, 5 and 6.